Now let's see about the cuts and connectivity. In this topic we are going to see about the vertex cut. So what is vertex cut is, if you remove some of the vertices from the graph, if we can get more than two components, more than one component by removing some vertices, such a vertex set is called as vertex cut. Okay, see this, a separating set, it is also sometimes called a separating set. So a separating set or vertex cut, both are one and the same, of a graph G is set S subset of vertices of G such that G minus S has more than one component. So what they mean by this is, let's say this is a graph. In this graph you try to choose few vertices, any vertices, in such a way that if you delete the vertices and the edges which are incident on them, the resulting graph should have more than one component. For example, let me name these vertices. Let us say this is 1, 2, 3, 4, 5, 6, 7, 8. Now there are 8 vertices. Now I will choose one vertex 3. Now this vertex set will become a vertex cut. The reason is, or it is sometimes called as cut vertex. Now the reason is, if I delete this vertex, it is going to divide this entire graph into two components. So this edge will be gone, this edge will be gone, this edge will be gone. Now what will remain? 1, 2, 8, 7, they will all remain in one component, and 4, 5, 6, they will all remain in other component. Now since we are getting two components, by deleting this vertex, this set containing that vertex is called as vertex set, right? And it need not always be single vertex, or a vertex set is not always unique, a vertex cut is not always unique. So what I mean to say is, you can also disconnect this graph or make it into more than one components by deleting some other vertices as well. For example, here you could have deleted vertices 2 and 7. If I delete 2 and 7, then I will be getting one component containing 1, 8 and other component containing 3, 4, 5, 6. Again I got two components, which means more than one component, and therefore 2, 7 is also a vertex cut, right? Maybe if you want to see, yes, I can also include 3. So 3, 2, 7, it is also a vertex cut, right? Or I can also include 3, 2. See, if you get a vertex cut, any superset of it is also going to be a vertex cut, isn't it? But then don't try to include all the vertices in the vertex cut, because if you delete all of them, nothing will be remaining there, right? Okay, now these are all the examples of the vertex cuts. Okay, let's take the next definition. The connectivity of a graph capital G, which is represented by kappa of G, is the minimum size of the vertex set S such that G minus S is disconnected or has only one vertex. So there is a basic difference between these two. When we are talking about the separating set or vertex cut, we want to always see more than one component in the resulting graph after deleting the vertices. Now coming to the connectivity, which is a number which is represented by kappa of G, it is a vertex cut which will either make the graph disconnected or it will leave one vertex. Got it? Therefore connectivity of every graph will always be less than or equal to n minus 1. Why? If you try to delete all the n minus 1 vertices, one vertex will remain. So you can call the remaining n minus 1 vertices as the connectivity of the graph. Are you getting this? So what I mean to say is, let us say you have n vertices in the graph, right? Now according to this definition, what is the connectivity? Connectivity is minimum number of vertices that you should remove in such a way that either it get disconnected or it has only one vertex. In worst case, what you can do is, if you are not able to disconnect it, then you can remove all the n minus 1 vertices in worst case and then leave one vertex there, right? So when will this happen? In a complete graph. Therefore in a complete graph, always the connectivity is going to be n minus 1. Okay, before going to complete graph, later we shall see about complete graph in detail later. First let's focus on this graph. In this graph, what would be the connectivity? What is the minimum number of vertices you can remove from this graph in such a way that you are going to make it disconnected? 1. isn't it? What is that vertex? 3. Therefore, connectivity of this graph is 1, and it is also called as one connected graph. Now, if you want to see one more example, let us say we have this graph. What is the connectivity of this graph? Now, if you observe this, in order to make it disconnected, I have to remove at least 2 vertices, because it is completely a cycle. In a cycle, there will be 2 paths between any pair of vertices. Even if you delete one vertex, one path will be gone, but all the vertices will be connected by some other path. That is why you are supposed to delete at least 2 vertices. Therefore, connectivity of this graph is 2. If I delete these 2 vertices, then they will be disconnected, or if you delete these 2 vertices, then it will be disconnected, right? You delete any 2 vertices, or any 2 you cannot say, but then you have to delete them in such a way that one of the, okay, see what I mean to say is, if you delete this one and this one, the resulting graph will be connected, right? Any 2 vertices you cannot delete, but then you have to delete non-adjacent 2 vertices. Any 2 non-adjacent 2 vertices, if you delete it, then the graph is going to be disconnected. So the connectivity of this graph is 2, and it is also called as K connected, which means 2 connected graph. Got it? What about the connectivity of a complete graph? In a complete graph, if you observe it, see, this is a complete graph, right? K3. If I delete this, you are going to have K2. If I delete this, then only you are going to have a single vertex. Now, according to the definition of connectivity, if it has only one vertex, then also it is called as connectivity. Therefore, in a complete graph, the connectivity is n-1. Right? Okay, we shall see about it later. Now let's look at the next one. A graph is K connected if its connectivity is at least K. So what is its meaning? A graph is said to be K connected only if you have to at least remove K vertices and get a disconnected graph, or a graph with only one vertex. So the meaning of this one is, you should not be able to remove K minus 1 vertices and get a single vertex graph, or a graph having 2 components. In that case, you cannot call it as K connected. If you are able to remove K minus 1 vertices, you should call it as K minus 1 connected. Got it? Okay. A clique has no separating set. So what is the separating set? See, the difference between connectivity and separating set is, in a separating set, we should always look at more than one components. We should always get more than one component after deleting that set. In connectedness, either you get more than one component, or if the graph should contain only one vertex. Both of them will be applicable for connectedness. Now, if you look at a clique, what is a clique? Clique is the maximum possible subgraph in a graph which is complete. Got it? So in this example, clique is this one. Right? Now, even it is not just applicable for clique, you can also take this definition and apply for a complete graph. Even in a complete graph, you will not have a separating set. The reason is, in complete graph, if you remove the vertices, whenever you remove a vertex, you will be getting a smaller complete graph, right? Therefore, there is no way you can get more than one components in a complete graph by deleting the vertices, because all the remaining vertices will always stay connected and they will always remain in one component. That is why for a complete graph you can talk about the connectivity because of this exception, having only one vertex. But then you cannot talk about separating set, because for a separating set you are supposed to see more than one component. Got it? Therefore, in a complete graph or a clique, you will never have any separating set. But then you can talk about connectivity. Why? Because connectivity is nothing but either you get more than one component or a single vertex remaining, that is called as connectivity. Got it? Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177, and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.